Dear students, in today's class we are going to prove an interesting result, that is nothing but characteristic of an integral domain is either 0 or a prime number. So let us begin. So I will say let R be an integral domain. Now if you recall the definition of characteristic of a ring is either a positive integer or it is 0, right? There are only two choices for it. If characteristic of R is 0, then we are through, right? Because that is exactly what we have to prove. Characteristic of integral domain is either 0 or a prime number. If I will say characteristic of R is equal to 0, then we are through. Now let us assume that characteristic of R is some positive integer. So I will say let us assume that characteristic of R is actually equal to n. Now it remains to show that this n is actually a prime number. But just wait. In order to prove it, we need one result that we have proved before. And what was that result? Characteristic of R is equal to n if and only if the order of multiplicative identity is actually equal to n in R plus, isn't it? So I will say this implies order of multiplicative identity, we are calling it as 1 is n in R plus. Now it just remains to show that this n is prime. Now in order to prove this n is a prime number, we are going to take the help of proof by contradiction. So we will say on contrary, assume that n is composite. Now what is the definition of composite number? Composite number means n is composite means n can be written as product of two integers which are greater than 1 and strictly less than n, isn't it? So I will say this implies n can be written as m1 multiplied by m2, where m1 and m2 are integers such that this m1 and m2 both are greater than 1 and less than n. Now just remember, what we have is order of 1 is equal to n. What is the meaning of it? Meaning of it is n is the least positive integer such that this n into 1 is actually equal to 0. But just wait, do we have the value of n? Yes. What is that? m1 multiplied by m2. So this value of n can be used here. So this implies m1 multiplied by m2, and how can you write this 1? 1 is unity, right? So you can always write it as 1 multiplied by 1. But the question is why? Because we have to use this result. So what does the result say? In a ring R, for any choice of integers m and n, and for any choice of elements in the ring R AB, this result holds. So why? Value of a and b actually are taken by the unity element, and these are actually the integers. So by that result, how can you write this? This can be written as m1 multiplied by 1 into m2 multiplied by 1 is actually equal to 0. But R is an integral domain. So what is the meaning of integral domain? A commutative ring with unity, and the second condition is without zero divisors. But the question is, what do you mean by ring without 0 divisors? If we are having two elements of the ring whose product is actually equal to 0, then either this element should be 0 or this element should be 0. And that is exactly what we are having here, right? So this will imply m1 dot 1 is equal to 0 or m2 dot 1 is equal to 0. Since it is or here, either this will hold or this will hold. So without loss of generality, let us assume that this holds. So I will say without loss of generality, assume that this m1 multiplied by 1 is actually 0. And where, what is our value of m1? m1 is greater than 1 and less than n. Is it true? Because on one side we are saying n is the least positive integer such that n into 1 is equal to 0, and on other side what we are having? We are having one more positive integer which is strictly less than n, and m1 into 1 is actually equal to 0. This is a contradiction, right? So we will say which contradicts to the fact that order of this unity is actually equal to n. Therefore, our assumption is wrong. What we have assumed? We have assumed that n is composite. Therefore, what should be right? Therefore, n should be a prime number. So what we have proved? So now we have proved that characteristic of an integral domain is either 0 or it is a prime number.